Alright, so here we are at number 4. Once again, we're going to use substitution and we're going to graph these. So something that's really handy right now is both of these equations are solved for y. And since the solution to this system is where the two graphs meet up, they'll have the same y value, they'll have the same x value. And so since we've already solved for y, we can take each of these sides and set them equal to each other. Like 4x plus 3 equals negative x minus 2. So notice this top right side got put over here, and the bottom right side got put there. And now we just have to solve this one. I'm going to choose the left side for my variable. So I'm going to get it out of the right side by adding x. What you do to one side, do to the other. You got 5x now plus 3 equals, no more x's, negative 2. We need to get rid of the 3, so subtract 3. We got 5x equals negative 5, because negative 2 minus 3 is negative 5. Divide by the 5, divide by 5. You got x equals negative 1. Alright, so we got one of the variables down. All you have to do now is plug it in to one of your equations. I'm going to plug it into the bottom because it looks easier to deal with. And we get y equals negative 1. Don't forget that when you plug it in, it's kind of like it's in parentheses. And then subtract 2 afterward. The double negative makes a positive, so you got 1 minus 2. And now you got 1 minus 2, which brings it back to negative 1. So now we have y equals negative 1 and x equals negative 1. That gives us the point negative 1, negative 1. And we have solved by substitution. Now that we've done that, we're going to skip right to the graphing. And something very convenient is the fact that they're already in the y equals mx plus b form, which is kind of what we're used to when we're graphing things. So let me rewrite those real quick on the coordinate grid. Okay, so I got them written down. I'm going to graph my left one with red. That's got a y-intercept of 3, so I'm going to put that there at 3. And has a slope of 4. That 4 in front of x means 4 over 1. So I'm going to rise 4 and go to the right one. So I'm going to go 1, 2, 3, 4, right one. Bam, put a dot right there. And I can't go any more to the right, so I'm going to go left. And when you go left, you just do the opposite. You go down 4, 2, 3, 4, and you go left 1. Ta-da! And now we got some points down. We can graph it. Drawing this lovely line that's not straight at all. Here, let me retry that. Yeah, something like that. I try to graph that away. And ta-da! We have a lovely graph for that equation. Now I'm going to graph the right one with green. This has a y-intercept of negative 2, so I'm going to put a dot there. And there's a negative in front of the x, which means my slope is negative 1, or negative 1 over 1. So I can graph this by going down 1, right 1, putting a point there, down 1, right 1, putting a point there. Or I can go the other way. I can go up 1, left 1, put a dot there, up 1, left 1, put a dot there. And my graph is starting to look like this. And this one actually came out really nicely for our graph. Our solution is right there, which is negative 1, which actually matches exactly what we got when we used the substitution method. So in this case, graphing worked out and got us the solution we're looking for.